Alright, in this problem, we have a rock that's kicked horizontally off of a cliff at an initial velocity of 21.0 meters per second. It falls a distance y and hits the ground with an angle theta equals 50.0 degrees. So I'll define my x direction as positive in the right, y direction as positive downward, with my 0 point being the top where the rock is kicked. Now, we want to find the distance y. We get our knowns here. We have theta is 50.0 degrees. Our initial x velocity is 21.0 meters per second, the same as our initial velocity because it's kicked horizontally. So it's directly in the x direction. All our velocity is x directed, meaning that our initial y velocity is 0 meters per second. Our final velocity is also 21.0 meters per second because there's no acceleration in the x direction. So our initial x velocity equals our final x velocity. Now, we want to find y. To do that, we can use this formula here. Assuming we know both velocities, our final velocity and our initial velocity, in the y directions, because we're trying to find y. Now, we know our initial velocity in the y direction is 0. We just don't know our final y velocity. But to figure out our final y velocity, we know our final x velocity and the angle at which it hits. So we can just use some trig to figure out what our final y velocity is. So making a triangle, a velocity triangle, we have Vx final, which we know to be 21.0 meters per second, Vy final, which we don't know, and theta. We can say tan theta. So opposite over adjacent, so that's Vy final over Vx final. We know theta, we know Vxf. We could solve this for an answer right now to get actual numbers, but I'm just going to say Vy final equals Vx final tan theta. And what we're going to do is plug that in this formula. So our V1 squared equals V0 squared plus 2ay is basically, in the y direction, it's going to be Vy final squared equals V0 squared equals V0 is 0. So I'm actually going to plug that one in because that's an easy one to start off with. 0 meters per second squared, 0, plus 2 acceleration times y. And we're just looking for y. So let's solve this now. We can say y equals, basically I just divide 2a over. So I have Vy final squared over 2 times acceleration. Now all I have to do is plug in my numbers to figure out what y is. Y equals Vy final is Vx final tan theta. So I got Vx final tan theta. Still squared divided by 2 times acceleration. So I just plug the numbers I know in here. Vx final is 21.0 meters per second. Times tan theta, which is tan 50.0 degrees. This is all squared divided by 2 times 9.8 meters per second squared. Now, this acceleration is positive because I've defined my y direction downward as positive. So this acceleration downward is positive as opposed to negative. Okay, so if I multiply these through, square it, divide by these numbers, I get a final answer of y equals 32.0 after rounding to 3 significant digits. And if I look at the units, I'm going to have meters per second, which is going to be squared. So I'm going to have meters squared per second squared and meters per second squared. So the second squareds cancel, and I have this meter divides into the meters squared, leaving with meters on the top. So y equals 32.0 meters.